Thank you.
Okay, it's now 1 p.m. Europe time, so it's time to kick off this Bess meeting session. Again, a new online session that we have to do, unfortunately. Let's start our review. So the not well. So if you are not aware of the not well, please have a look and ensure that you are complying with the rules that are displayed. Here is our agenda. So the agenda was quite packed, but at the end, a few session slots have been cancelled, so we have more time. We have a session at the end from Kaliraj, which was under time permitting, but I guess we should be able to handle this session.
Thank you, Stefan.
Status update. One RFC has been published since last time. So this is the revision of the 5549. And this is the only one published. We still have bunches of documents in the RFC editor queue, mainly due to some dependency, especially for the VPM prefix advertisement, where we still have a dependency on the inter-subnet forwarding draft, which has been in ISG and AD for a long time, and there are still pending discussions. So I don't think we have Ali. We don't have Ali on the connected. Martin, maybe can you give you the latest update on the inter-subnet forwarding draft? I think there is still a pending discuss regarding how the MPLS label 2 is referenced, and how we should mark the document as updating the 7433 existing RFC. Do you have any update on this one? Yeah, I see on the chat that Martin has some audio issue, so maybe he's not able to hear me. But yeah, we still have some couple of things to address in this draft to make the ASG happy. We also have a couple of discuss on the EVPN ANA flags and proxy ARP ND, mostly because of the ND aspects, of the IPv6 aspects of the proposal. So Jorge, I have seen that you have restarted the discussion with the IESG. So do you think we will be able to come to a resolution regarding these two drafts?
Can you hear me?
Yes.
Yeah, so the NA flags, I think I cleared all the discuss, but there is one remaining comment that I need to go back to the reviewer and see what else we need to do. The other one, I'm actually replying to all the emails and resolving all the discuss.
Okay, and do you think there is a major point that we will not be able to resolve easily, or do you are still confident that this is manageable and we don't have to put the document back to the working group?
I still need some more time to look into the comments. Yeah, specifically as you said, for the ND part, the R part seems to be okay. Yeah, but
Okay.
I need a bit more time.
Okay. Okay. Thank you, Jorge.
Yeah, thanks.
And we have a couple of documents that are still under Martin. Discussions are ongoing, or Martin still has to provide its review. We have also a couple of documents under Shepherd review. So Monkamana is closing the review on the IRB multicast. On the virtual Ethernet segment, there are a couple of discussions that are still ongoing. One of the, I would say, issue which is happening in the draft is now the Shepherd has taken over the edition of the document, which is not really good. The Shepherd is really here to help solving the issue, driving the document forward, but it's not really his job to do the edition. So we really need support for the all the co-authors of the document to make the appropriate edition, so we can move forward. EVPN PrefDF, there was a couple of pending discussion on this one, especially on the highest and lowest priority and how we do it. I think we are really close to a resolution, so the document should be able to move forward quickly. MVPN, EVPN aggregation label, it's pending my review, so action is on my side. SRv6 services, so there was a very good review provided by the routing directorate, and all the comments have been addressed, and a new revision of the document has to be posted, or maybe it has been posted at the beginning of the week. I haven't checked. And Matthew has to provide the write-up for the document.
Yeah, there's a bit of discussion on the list about it. I did post an update, I think, and there's a little bit of discussion going on the list, so we'll see that settle first.
Okay.
Martin has given comment on inter-subnet forwarding draft that it will lose ballot because of IESG change, and it will have to go through another telechat.
Sure. Okay, status of the last polls that we have sent. So there was a recent poll on the EVPN IRB extended mobility. So the poll has been closed, and Niraj has to provide a couple of updates, very minor comments, but it needs to be addressed before moving forward. On VPWS FXC, unfortunately, and this is not the first time, we really got very few response during the poll, which is putting us chairs in a very bad position, because if we have very few responses, it's really hard for us to tell if there is a really good consensus to move the document to the next step. So we will extend the poll, and we are really requiring feedbacks, positive or negative, with comments to ensure that we can move forward with the document. On the EVPN LSP ping, we are still waiting on the MPLS chairs, because at some point after the working group last call, the IANA consideration section was not written in a good way, because MPLS was doing some change in the registries and so on. So the change has been done, but we need to have the MPLS chairs validating what has been done, so we can move forward. On the weighted HRW, there is still one IPR reply which is missing from Ali. So we cannot move forward until we are closing all APRs. We don't have any document yet which is ready for its first working group last call. However, we have two documents where we need a new working group last call because there was some substantial comments that have been addressed or changed, introduced in the draft. So we need a new working group review, and we will proceed right after the IETF with this new short working group last call. So the first one is the unequal cost load balancing. So there was some controversy, a couple of IETF backs of reusing the existing link bandwidth communities and so on. So everything has been solved. All the references have been cleaned. So we need a review again of the working group to ensure that we can move forward with the new with the latest version. IGMP, MLD proxy, there have been a lot of comments addressed, and I think Luke has also provided additional comments. So the author will have to look at the new comments that have been provided, and as soon as they have been addressed, we will again do a new shorter working group last call for this one. We have one new working group document from the last IETF, which is the EVPN redundant multicast source, and we don't have. We just have a single document which is ready for working group adoption in our queue. So if you think that your individual document could be ready for working group adoption, don't hesitate to poll us. You don't have to wait for an IETF to do that. Just send us an email and we will assess if your document could be ready and if we can add it in our queue. Working group document updates. I will not go through all the updates that we have received. There are a couple of documents that are on the agenda, so we will get also some update during the session. There are a couple of them where we have no status. So SD1 usage, there was a slot scheduled for this one, but it has been cancelled. So we don't have the latest update. I don't know if Linda is connected. Do we have Linda? No, we don't. PBB, EVPN, IC, CMAC flush. Maybe, Jorge, I don't know if you can provide a very small update on this one. Just one sentence to.
It's actually ready. So we presented it last IETF and we actually requested last call.
Okay, so we are missing it in our list. So yeah, in this case, don't hesitate to check the wiki to ensure that our queue is accurate. And if we are missing anything, don't hesitate to contact us again. Okay.
Yeah, thank you. I had one more question about the EVPN IPVPN interworking draft. I know there was some discussion pending with the IDR working group, but I haven't seen anything happening in IDR. So
yes, exactly, and this is what I have put the comments that I'm still pending some replies from the IDR chair. So there was, if I remember correctly, 2 points to address and discuss, which were the rules of aggregation and also the how we are managing the propagation of the attributes, especially what process do we need to introduce between the two groups to ensure that every new attribute is getting the right propagation rules. So I think we have Jeff and Sue connected. Maybe I have missed the reply, but I haven't seen anything on my side. Sue and Jeffrey? Any comment on your side?
No, I'll answer since it's my fault. Due to the chair switch, we're behind on a few things. We will try to get back to you by the first week or so in April. Okay.
Okay. Yeah, absolutely. But yeah, this is something that we really need to close because today it's blocking the progression of our document.
I have it as one of the first things to do on my target list after dealing with a couple problems with on open working group calls. So yes, I understand.
Yeah, and if we need to set up a call between chairs to discuss that point, there is also absolutely no issue. We can set up that to speed up the resolution as well.
Again, after ITF, people usually take a week off, but after that, let me make sure I'm aligned with my other new chairs. I will be missing John and all his good work. You know,
Sure.
but after let me discuss it with my new chairs. I have been at least trying to bring them on board. After that, I will probably send you and the other chairs my write-up, because some of the original discussion was mine. Thank you.
Thank you, Sue. Okay, and I have an issue with two other drafts. So the first one is the FastDF recovery, because currently the draft is having multiple solutions, and one which is the NCheck solution looks really complex. Not sure that it's well proven. So I'm really wondering how we should move this document forward. And if one of the solutions to move the document forward could be to split the document and to have the discussion of the NCheck completely separated. So I would be happy to hear the opinion of the editors of the draft regarding how they see the progress. And the other one is EVPN Geneva. So there was a couple of comments after the working group last call, and the draft has expired and nothing has been replied. And so the draft was edited by Sami, if I'm not mistaken. And I guess Sami has moved to some other responsibility. So I'm even not sure that he actually wants to continue the work on that one. So I will try to pull him again. And in case he don't want to continue, we may need a new editor to close this draft. And this is what we have for our presentation. So if there is no particular question regarding our status, we will move to the presentation. Gian, you are the first one.
Okay. Hi, my name is Gian Mishra. Sorry. Hi.
Yeah, right, we can hear you.
Yes. Okay. Hi, my name is Gian Mishra. I'm with Verizon, and I'm providing an update for this draft. So this draft, primary use case related to this draft is to be able to carry IPv4 NLRI over an IPv6 next hop. So with this draft, the major update that we've had with this draft is we have 5 vendors on board supporting this use case. So this primary use case is it covers any use case where you have any type of edge peering. So eBGP, edge peering, PEC peering, either core or data center, enterprise or service provider, where you have dual stack peering. So now instead of having dual stack peering, the best practice would be once the interoperability testing is completed between the 5 major vendors in this draft is published, is that we would now be able to carry that v4 NLRI over an IPv6 next hop. The major gain is that we would eliminate all v6 peering on the edge peering, and it does allow the further proliferation of IPv6 and elimination of edge. So OpEx savings, so no more VCD4 addressing on that edge peering, as well as OpEx costs to maintain the v4 edge peering, and of course IPv4 address depletion. The 5 major vendors that we have on board that confirm supporting this feature, we have from Cisco, we have our representative Manikma Mishra. From Juniper, we have Lily Wang. From Nokia, we have Adam Simpson. And from Arista, we have Qing Yang. And then finally, from Huawei, we have Shenglong Chen. So those 5 vendors are the folks that I've mentioned are the primary point of contacts for the interoperability testing and logistics of getting the interoperability testing completed as quickly as possible. Our goal is to get the, once this draft is adopted, we would like to get start on logistics related to the interoperability testing for this document. As the support is there, but we want to make sure that any operator around the world, we have gotten some feedback, Verizon included, that they want to start the proliferation of IPv6 on the edge and elimination of E4 peering. So this is a hot draft that I think a lot of operators around the world can really take tremendous advantage of this draft. So once we've achieved workup adoption, we'll start on the logistics testing and try to advance this draft as quickly as possible. If you could go to the last page. Thank you.
Yeah, because you have a lot of slides. So, and you just requested 5 minutes.
You can just go to the last slide. It's okay.
Is that
Okay, so we have all 5 vendors on board, and then if you can go to the one slide before this, and this is workup adoption. We're just the workup adoption. Okay, there you go. So so we would like to ask any feedback from the work group related to this draft progressing as a best practice. We have had a lot of feedback from operators, Verizon included, as I mentioned, and we have the 5 vendors on board. And we want to start the interoperability testing as quickly as possible, as this is a hot topic, and as there is tremendous gain to eliminate the V4 peering, the edge peering. One last thing I want to mention is that in discussing with the 5 vendors, we did talk about the RFC 5549 to RFC 8950 update, which is related to the SAFI 128, 129 next hop encoding, where 5549 was a 16-byte and 32-byte next hop encoding, which did not have the RD field included. So the update is to 24 and 48. So as a primary use case for this draft is for SAFI 1 IPv4 unicast carry over IPv6 next hop, we decided that for this interoperability testing, we will just test that primary use case. And really the goal is to get this get the interoperability testing done as quickly as possible so we can progress this draft and get it published so operators around the world can start the elimination of V4 and the overall IPv4 and address depletion issues on major peering points that folks around the world can start immediately taking advantage of that primary use case. Thank you. If anyone has any feedback, I think I can just open up the floor if they have a minute or two for anyone who has any questions or comments on this draft. Thank you.
Any comment? I don't see anyone. Quick question. I have seen that you have set the document as a best practice document. Is it the right status for this one?
Yes. So I've changed it. It was standards track, and I changed it to best practice. So this would become like the ubiquitous best practice for any edge peering to carry IPv4 and LRI over an IPv6 next hop. Once we complete the interoperability testing, this would make this the official practice for any operator. They can look to this document as that primary use case to help with that proliferation. And we have all the results of the interoperability testing, in this draft. So anyone looking at this draft once published will feel comfortable. The operators around the world will feel comfortable that they can start that elimination, V4 elimination.
Okay, so we will take your request to the list. We don't have any additional comment. Thank you again.
Okay, thank you.
Next one is Donald for EVP and BFD.
Hi, it's Donald Eastlake. I'm just going to give a quick update on this draft. We got a lot of things on the agenda, so I don't want to take too much time. Next slide. So this talks about EVPN BFD draft, which is about fault management for the network layer. The last part of this slide is incorrect. EVPN OAMR requirements framework, is not in the editor's queue. It's awaiting write-up. So I can send corrected slides if you like. Next slide. So this shows the OAM framework that is in that draft, which is awaiting write-up. And this draft I'm talking primarily about here, it concerns the network OAM layer there between the PEs in yellow. Next slide. So this just talks about the other layers briefly and what kind of technology you would use for connectivity checking in these other layers, including, of course, the end-to-end Ethernet service of EVPN and CFM for that. Next slide. So this draft, EVPN BFD, talks about BFD proactive fault detection, and it covers MPLS and VXLAN encapsulation, unicast traffic using point-to-point and multi-point-to-point, phone traffic using multi-point-to-point, and phone traffic using point-to-multipoint. Next slide. And these are the things that are out of scope. It does not talk about packet loss or delay measurement, other encapsulations beyond that, IRB, multi-point to multi-point, or BFD echo. Next slide. So what's changed? The previous draft was a little unclear. It tended to speak about OAM and fault management pretty generally, at least in the sort of introductory and the high abstract and stuff like that. This draft is clear that it's just focused on network layer fault management. This draft includes an extension to the BFD discriminator path attribute. I'll talk a little bit more about that on another slide. The existing attribute only covers BFD active tails point-to-multipoint use. It allocates a unicast MAC address as well as a multicast MAC address for use as an inner MAC address when you need that. And it, as usual, has some minor tweaks and editorial clarifications from the 02 version. Next slide. So on BFD discriminator, this is specified in the Bess MVPN fast failover, which really is in the RFC editor queue. This statement is correct. And as specified in that draft, there's a BFD mode field, and it gives this attribute where you can associate a BFD discriminator with the path. It has the BFD discriminator, optional TLVs, and also this mode. And currently only one mode is specified, which is specifically for point-to-multipoint BFD sessions. So this draft adds a mode of the BFD discriminator path attribute for point-to-point BFD sessions, since it needs that. The TLVs there's one TLV defined. It's in the MVPN fast failover draft, which is for a source IP address, and it's required to provide the IP address of the multipoint head for a point-to-multipoint BFD session, and it's used that way in this draft as well as in the MVPN fast failover draft. Next slide. So, comments and suggestions welcome. The plan is, the plan by the authors is to add PBB EVPN to this draft coverage, and then to request working group last call, which we believe we should be able to do before the next IETF meeting. So I wanted to present at this meeting just to update people on the status of the draft. That's it.
Okay. Jorge, go ahead with your question.
Yeah, just wanted to say that, so last time I made a few comments and I didn't see any updates or any changes addressing those comments in the new version. So I sent an email this morning. So if you can look at it and address my comments, that would be great.
Certainly, thank you for the email.
Thank you.
Okay, thank you, Donald. I think we can
You're
move
welcome.
to the next speaker. Luca.
Thank you, Stefan.
So I'm going to be presenting basically a brief update on 2 drafts, defining load balancing modes for Ethernet segments. I believe, to be honest, that Stefan covered most of my update in the chair report, so I can be very brief and yield most of my time back to the working group. So the first one is the port active load balancing mode. So this is a draft which has progressed some 5 or 6 versions with the working group feedback before adoption. And even though this is just a 0.1 version, it is a relatively mature working group draft with multi-vendor support and adoption of several known implementations by service providers. And in our view, since since it's a mature draft and the port active is beginning to be referred to in other individual drafts and discussions as a third baseline load balancing mode, we believe it is ready for a last call. But obviously, any feedback is still welcome. Next slide, Stefan. So the Gateway Protocol draft has been around for some time also. This is a load balancing mode that addresses common migration scenarios for service providers with legacy access networks. There have been incremental updates based on working group feedback for each of these 6 versions. And this 6th version is no exception. It incorporates some more working group feedback also. It is still an individual draft, but it is mature. It has actually implementations and deployments. It is deployed. So we do believe the draft is ready for adoption. But here also, more comments are, of course, always welcome. That would be it for me, Stefan, on those 2 drafts.
Okay, I don't see anyone in the queue. I would like to understand from the group who has read the draft and who thinks it could be ready for a working group adoption. So I will start for the first time. I will a show of hands tool, so you can reply. Okay. Let me try to do that. Oh, sorry, I have put it the wrong draft name. So yeah, I'm talking about the EVPN L2 Gateway Proto, and please raise your hand if you think that the document is ready for working group adoption.
Keep in mind, you have to click on the tool in the upper right to be able to do this.
Thank you, Donald. Okay, we got very, very few reply for now. Okay, let's wait for 10 more seconds. Okay, thank you for your feedback. Okay, next speaker is Lucas.
Hello, Stefan, and hello, everyone. Thanks a lot first.
We can hear you.
Can you guys hear me? Very good.
Yeah.
All right, this is Lucas Kradiger from Cisco, presenting for the first time here in the Bess working group, the EVPN interoperability modes draft. We worked on that for quite some time over the last 2 years or so as a conjunction of multiple people across multiple vendors, and thanks a lot for my co-authors for all the input and also for all the rest in the working group. You want to go to the next slide, Stefan? So the idea behind this, or the broader spectrum, is that we have different modes in various EVPN drafts. For example, in service interface, we have section 6 in RFC 7432, which defines the different service interface modes. We have IRB draft, which defines 2 different forwarding modes there, and we have the IRB core connectivity as part of the prefix advertisement. So in all of these different drafts and RFCs, we have different use cases defined, and with different use cases, we have different modes of operation there, which are generally mutual exclusive as they are defined in there. But as we saw, given that not everything is really a must for implementation, and very often it becomes that some of these use cases are adjacent to each other, there is the criticality for interoperability between them. Next slide, please. So the key focus on this draft is in the area of service interfaces, integrated routing bridge, and IRB core connectivity model. So we aim in this draft to achieve interoperability between these different defined modes, and we don't really want to redefine all of these different functions which are present in the various drafts and RFCs, but we want to make sure that there is a clear mode of operation documented and defined in how these different modes can interoperate to each other. Given that there is a vast amount of variations there, I think there are 3 or 4 in RFC 7432. There's only 2 in the IRB draft, but there are 3 then in the prefix advertisement draft. So we look at the most pertinent modes. We can always at the interoperability between VLAN-aware bundle and VLAN-based, the service interface in RFC 7432, the asymmetric IRB and the symmetric IRB, the SO2 IRB modes which we have in the inter-subnet draft, and then the IRB core connectivity model. We look at the interface less and the interface full unnumbered mode. Next slide, please. So this is a short overview of section 3.2 of the draft itself, meaning the interoperability of the 2 service interfaces there. You see on the very left-hand side, you see a VLAN-aware bundle service PE. You see on the right-hand side a VLAN-based service interface PE. And in the traditional mode, which you see on the top left with BD1, BD6 in green with a MAC VRF2 of P1, you see how normally you would advertise these bundled PE, bundled BDs within there with the classic multiple BDs per EVI, the IETF information there, and the common route target for the whole MAC VRF. When it comes to VLAN base, we have different attributes which are required. For example, we don't care or we don't want the Ethernet tag to be present there. So in order to interoperate, we ask in this specific model on PE1 to go into a single BD per EVI mode with a clear route target for that MAC VRF assigned, and sending with an IETF of 0 how the VLAN-based mode actually would also define it there. So it's kind of a hybrid for the service interface on PE1. It has a set of BDs which are operating VLAN-aware mode versus it has other MAC VRFs or other BDs which are operating in the VLAN-based mode to achieve that interoperability between the 2 different service interfaces. Next slide, please. Section 4.2 specifically, and Section 4 overall, is focusing on the IRB interoperability. We look there at the asymmetric IRB, the symmetric IRB. We defined on what is actually required from the asymmetric IRB to be sent, that symmetric IRB or hybrid IRB mode here in P2 represented would be able to achieve communication. We define them as advertising the MAC IP routes from the asymmetric IRB as it's traditionally been there, but then the install of the specifics on the symmetric IRB, we would again append that by basically allowing the MPLS level 1 as well as the MAC IP bindings to be installed over the L2 tunnel. On the PE2, we also anticipate that there might be other other PEs which are non-interoperable with the asymmetric IRBs, so we would allow that symmetric IRB to symmetric IRB to stay existing there. Next slide. The last section or the last area of interoperability is around section 5, which is the IRB core connectivity modes. You see here on the left-hand side the interface less model. You see on the right-hand side PE2, the interface full unnumbered model. So here again, we are defining on what is being needed in order to get interoperability between these different connectivity modes. We see the interface full unnumbered IRB requires an additional MAC IP route to define or to create the recursions for the next hop there, which interface less doesn't need. So we ask the interface less PE to advertise an additional MAC IP route with the respective information there, respectively PE2 to evaluate that, and in the other direction for the interface full unnumbered IRB. We have that implicit advertisement of the additional MAC IP route, so we will ignore that on the interface less side as defined in the section 5.1. Next slide. So status of the draft, as said, we submitted first in July 2019. We did a lot of field work prior to that. We're currently in version 0.3. There's a version 4, which we are going to do with some minor updates and hopefully with a lot of feedbacks from the working group itself. We have actually implementation at various stages at various vendors. We did some active testing with Juniper and Nokia, I mean Cisco, Juniper, and Nokia as part of the multi-vendor interoperability showcase at ENTC. It went over various years. It was always aimed at the least amount of need from another implementation, meaning one of the other service interfaces or IRB modes or IRB connectivity modes are there for achieving the interoperability on the side of the other vendor. Next slide, please. So with this, what we achieved, for example, the service interface interoperability, we did VLAN based on a Cisco PE, and we had the Juniper VLAN Aware bundle implementation there and did interoperability there. Thanks a lot for all the helps there from various people from Juniper during this ENTC event. We actually also did the IRB interoperability. Was very interesting because at that point, the implementation of the Cisco symmetric IRB was kind of seamless, or let's call it hidden to everyone else, and we achieved with Juniper the asymmetric IRB implementation as well as a couple of other vendors. IRB core connectivity, we do that interoperability testing for a couple of years now to get with Nokia, which has the interface full unnumbered implementation. So we achieved already a very good set of interoperability as discussed in the draft itself, and have implementations there in order to achieve this. Next slide, please. So as we are here at IETF 110 online, we're asking for working group adoption and also for feedback from the working group, from the community on this draft. Thank you very much.
Okay, Wen, you have a question?
Yes, I have one question, one comment. First, the question is about symmetric and asymmetric IRB support. For the P support symmetric IRB, what it will be it's a forwarding behavior when it does the inter-subnet routing. Is it gonna do layer 2, eventually do layer 2 forwarding to P1?
That is correct. When we would do layer 2 forwarding to PE1 post routing on ingress on the asymmetric side. That is in one direction. In the other direction, we would do exactly the same, would actually behave kind of an asymmetric IRB PE on the symmetric IRB PE side. So kind of a hybrid at that point.
Yeah, thank you. So it'll be nice to spell out in the draft, because as if P support symmetric IRB can behave that, they to support this draft, they change the code. Yeah, thank you.
Okay, very good. Thank you very much for the feedback.
Yeah, so the other comment is about VLAN aware and the VLAN bundle service, VLAN based and the VLAN aware bundle service. And I think the draft said the VLAN aware bundle service must have one VLAN, only one bridge domain. For VLAN aware bundle service, usually people choose this service interface service mode. They have a multiple VLAN inside macRUF. I think it is an option to support BD aware route target, because the route target is the key for the interrupt between two service modes. So I would suggest to remove the keyword must, also maybe consider support the interrupt with VLAN aware bundle service with more than one bridge domain, and require each bridge domain to have ED specific RT. So maybe we can talk offline on that if there is anything missing for that.
No,
option.
sure, absolutely, man. We can discuss that offline as well. One comment I would like to make is that in signaling to a VLAN-based PE, you require not only the BD-aware route target at that point, you would also need to ensure that you're not advertising the ETH attack identifier to be different than 0.
That's right.
Yes, we could ignore it on the receive side, but it would be better to have clear signalization that this is a single BD per EVI mode at that point, and the clarity on the route target if the sending side, meaning the VLAN aware PE, would send it in the proper format to the VLAN based one. But from the rest what you mentioned, that sounds absolutely fair, and I'm happy to discuss that further.
Thank you. Yeah.
Absolutely. Thank you very much, man.
Yeah, it's a very useful document.
Thanks a lot. I'm remembering back when we did the testing together between VLAN aware and VLAN base.
Yeah. Thanks.
Thank you.
Okay, thank you, Lucas.
Thank you very much.
DJ, you are the next one.
Hello, can you hear me?
Yeah, absolutely.
Oh,
Go ahead.
Great. Thank you. Hello, everyone. I'm Dhananjay Rao from Cisco, and I will present on behalf of my co-authors and contributors. I have 2 drafts to present. First, the BGP color-aware routing problem statement draft, and followed by a solution proposal. Next slide, please. The objective of BGP color-aware routing is to use BGP to establish an end-to-end intent-aware path across multiple domains. Domains could be IGP or BGP based. The word intent is a bit abstract, but a simple example is a low latency path between 2 PEs in a network. Next slide, please. A quick reminder, here in the IETF, we have defined a solution for interdomain intent or SLA-aware path computation using SRTE. It is a mature, widely deployed and supported solution. The solution documented in this draft defines the notion of color to represent intent in the network control plane. Next slide, please. Here we see an illustration of the color concept in action. An egress PE E3 tags a VPN route with color C1, expressing a request for a particular intent for that route. Any ingress PE, such as E1, that installs this route will look for a path to E3 for that color. The color here is signaled using the BGP color extended community. Next slide, please. Now, in the SRTE solution, the ingress PE even may request an SRPCE that's in the domain to compute the interdomain path, since the SRPCE will be aware of the interdomain topology. the SRPC will return a label or a SID stack, which the PE will install and use in the data plane. The rest of the network doesn't have any state for this path. Here we could say, E3, C1 is a SR policy-based color-aware path in the underlay. Next slide, please. So we see here an evolution of that automated steering as the previous case, but here the interdomain path is set up using BGP, hop-by-hop route distribution, and best path computation. In this example, a route to E3 for color C1 is originated from a border router, say node 32, maybe originated from an IGP, and it is propagated hop by hop across the domains till it reaches E1. At each hop, a best path is computed, which may recurse over intra-domain color-aware paths. The VPN route in this case is steered via this BGP color-aware route, to E3 via like E3, C1. Next slide, please. Here we see an example where there are multiple, so 2 color-aware routes to E3, E3, C1 and E3, C2, which are independent routes that may resolve via different IGP paths in each domain and yield completely different end-to-end paths. And we see 2 VPN routes, one tagged with color C1, which will resolve via the E3, C1 route, and the other W/W, which is tagged with color C2, which will resolve via the E3, C2 route. Next slide, please. So when we look at the problem statement, we consider some of the basic parameters of the target deployments. The reference topologies are the well-known ones, but we observe a vast increase in the scale of the network. In some cases, to the order of a few 100,000 nodes in the network. And then we also see a number of intents that needs to be may need to be supported. We have listed some common ones. So even considering just these examples, there's like 5 intents with around 300K nodes. We end up with up to 1.5 million routes in the network, and that has some significant impact on on the protocol, and that's what we consider in the draft. Next slide, please. Here, we'll just list a few more intent use cases for reference. The draft goes into more detail with with topology and illustrations. Next slide, please. The primary focus of the problem statement draft has been to document a concise technical analysis and enumeration of the use cases with illustrations, with a specific focus on the deployment considerations and the resulting protocol design requirements for BGP. A few key aspects to call out here is, of course, consistency with deployed solutions. That's the SRPC-based solution. Here we again call out, the use of color to drive automated steering. We also realized the problem scope is wider than just the transport. Intent-aware paths may need to be supported in the VPN service layer, based on the feedback we received, both between say CE to CE across the provider core, but also beyond. And as well, because a provider network is also made up of different administrative authority, domains, if you will. There's a presence of various interworking options like interface option A and option B, and this intent awareness needs to be propagated across them too. Similarly, a support for NFV and service chain integration is also necessary. Next slide, please. There's also a list of deployment requirements noted. A key one to call out here is the fact that a multi-domain network is heterogeneous, has different technologies and encapsulations, and these need to be considered when defining the protocol extensions. Also, going back to my example about the scale, that has an impact on all the nodes in the network, both on the data plane, especially when MPLS is implemented or used, as well as on the control plane with BGP. And again, we list the considerations in the draft. Next slide, please. So this work is the result of a collaboration with many folks, both among the operators and vendors, and we thank the folks for their contributions. We also recognize that there has been work in this area, specifically by the co-authors of the Seamless SR draft. We reached out to them back in November, December to work towards a joint effort. Jim Utaro has helped facilitate these discussions. We published our technical analysis towards this effort. The Seamless SR co-authors have acknowledged our feedback and split their document into two. We are working together now to work towards a joint set of new documents. Next slide, please. This work is ongoing, but we welcome feedback and review from the working group. So I'll just stop here for a minute.
Do we have any comment regarding this problem statement document? I don't see anyone in the queue. So we can move forward, DJ.
Okay, sounds good, Stefan. So we now move to the to the solution proposal. Next slide, please. So from the problem statement analysis, it's clear to us that we need a new BGP SAFI for the ability to signal multiple routes to the same endpoint prefix, one per color. With that, the solution draft describes the essential elements that are needed, focusing on the aspects listed below. A thing to highlight here is we have focused on, because it is a new SAFI, we have focused on defining extensions that provide efficiency and extensibility and improve upon some of the legacy constraints we have seen in the past. Next slide, please. So yeah, so we start with the NLRI. I mean, this is the critical element. The NLRI key we propose to be endpoint comma color, where endpoint is the the IP prefix of the the traffic destination in the transport. That's say the PE address, and then color is the same 32-bit value that's used by SR policy. The color here serves two purposes. It distinguishes the route per intent, and it also indicates the intent that is satisfied by the route. Right? This color is defined by the user, and it's consistent on all the devices within network managed by an administrative authority, a so-called color domain, if you will. And of course, this color is, as mentioned earlier, the same as the BGP color extended community. Next slide, please. Why did we propose this particular data model? It's it's the simplest, it's the most precise. It has identical semantics as the one used for SR policy, automatically providing consistency. The routing semantics that follow from it are quite simple and straightforward. They're essentially the same as used for the BGP IP SAFI or the BGP labeled unicast SAFI. The simplicity has benefits both in the protocol processing as well as operationally for folks who run the network. A key benefit, it inherently provides ECMP aware and backup paths at every hop. For example, if there were two route to a PE originated from two ABRs, they automatically become multiple paths of the E, C prefix at an ingress node in that domain. This leads to a faster localized convergence within the domain driven by IGP detection, and also prevents this failure from creating churn beyond the domain. And of course, it's also the most efficient from a subscription or a filtering point of view as needed for the automated steering. Next slide, please. The other aspect we consider is the encapsulation. There is a need for multiple encapsulations even within a domain for coexistence and migration from one technology to the other. And we want to allow that the necessary signaling to be done efficiently and operationally simpler. So we use in non-key TLVs to signal the different encapsulation data for a route. We also, in terms of encoding, place the variable part in the NLRI, the rest in the attribute. The goal again being efficient packing of the BGP updates. Since this is a new SAFI, there is the opportunity to address some of the limitations that exist in the current SAFIs. Next slide, please. Extending on that same theme of extensibility, we also define an extensible NLRI model here. The details are in the draft, of course, but just as a quick intro, we encode a route type, to account for newer use cases that may, come up in future. We encode a key length to allow new route types to be opaquely, transited through transport RRs in the network. And we already, touched upon the use of non-key TLVs for the encapsulations. We recognize there are other ways to encode this data, and we look forward to feedback, but we have taken a considered first stab at it. Next slide, please. We reuse and leverage the AIGP attribute to convey the end-to-end metric for a specific color. And again, AIGP being an extensible attribute, we see scenarios where it can be extended to accommodate certain use cases. Next slide, please. Coming to the BGP car route validation and resolution, both, at every hop. This is the essentially the processing of the next hop. A BGP car next hop will resolve by default over another color-aware path that's present in the domain. That could be an IGP path, or it could be also another BGP path. When that color is not available, the resolution may happen via a different color, a path that is available in the domain, or in the worst case, it may fall back to the default best effort path. The model also allows for preserving the end-to-end color awareness, even if a transit domain actually does not support color. So it allows a way to get support over islands such as IGP, LDP, best effort islands, as well as BGP LU domains. We also propose to use the encapsulation after validating its presence programming in the data plane, and this validation can be augmented by a dynamic performance measurement system where needed. A second aspect from a resolution point of view, as I said earlier, the resolution is recursive, so it can happen via any available BGP or IGP mechanisms. Next slide, please. This is a callback to the service route automated steering that we noted in the problem statement. Is just indicating the the VPN route in this case, as it when it resolves over a BGP color aware route. There can be other options. It could be a combination. You have multiple options: BGP car, SR policy, IGPFA, and based on the preference, the appropriate path, end-to-end path would be selected. Again, given the presence of multiple domains with different encapsulations, an end-to-end path may have to go over different encapsulations. Next slide, please. So here we come to the case, albeit a corner case, where the transport network has to traverse across different color domains, that is domains where the color to intent mappings actually change. Now, this is not expected to be the common case. Usually, if the network goes across such different administrative authority boundaries, it is likely that there is a VPN layer interworking that is used, like in trace option A or B. But for the case where a transport may extend, we define a solution using an extended community to carry the local color mapping across such a boundary, such that this color then can get remapped to the receiving domain's local color and used within the domain. A key thing to note here is the NLRI of the car route itself is not rewritten; it is preserved end to end. The other thing is that, as noted earlier, the prefix is unique in the underlay network. Hence, the E, C tuple is unique even if C is local to a color domain. Next slide, please. So it can be noted, from the draft that the BGP protocol extensions themselves are, quite simple. But the complexity really comes from the scaling, requirement. And so we analyze the impact of scaling on both the data plane and the control plane. On the data plane side, we note the use of a few different designs, and we analyze the benefits of those design, on taking state away from the core border routers, for example, but with the resulting complexity at other points in the network, such as the ingress PE or the border router. And the same thing for the control plane. Next slide, please. Okay, yeah, so this is obviously the initial version, but we welcome feedback from the working group.
Jorge, you are in the queue. Go ahead.
Hey, DJ, thanks for the presentation. I have two questions about it. The first one, so in the new NLRI, you're including the route type and also the key length. And you mentioned that allows route reflectors to basically validate the key length and reflect the route even if the route type is unknown.
Yes.
That is a bit new compared to what we do with SAFIs that support route types, in the sense that today, for those SAFIs, route reflectors, if they don't know about a given route type, they usually do 3-dash withdraw as per RFC 7606. Don't you think that this new behavior is kind of a security risk, or at least this should be discussed in the security section?
We should certainly discuss that. I think the behavior you note for the exiting SAFIs, I mean, that is something that has driven the introduction of this this key length, because based on experience of introducing new route types, for example, with the VPN. So that's what motivated this. But we should certainly discuss the security implications. There are some other implementation implications as well. So we would certainly analyze them.
Okay, cool. And the second question is about the encapsulation part of the NLRI. So when you add the SRv6 set TLV, there's some text in the draft that talks about transposition. That got me completely confused, because there's no label here, right? So if you add the SRv6 set TLV directly, why would you transpose anything? So I don't know if you can clarify that, or maybe it's I don't know, the text is wrong. Can you comment on that?
I would say, let me take a look at the text, and then maybe get back.
Swadesh,
Yeah.
did you want to add something?
Yeah, so
I
so
see
like Hore, you are well aware of transposition scheme in VPN. So it's a similar concept that if we have a per prefix, we can carry the function part into with the NLRI for BGP packing efficiency, and the locator and the other part in the attribute. So it's on the similar lines. You are well aware. So it's exactly the same.
Yeah, no, but Swadesh, yeah, I'm aware of it. But my point is, here you are starting clean, so you don't even need to have a label in the NLRI, and you
No,
can
we
have,
won't have a. We will not have a label in the NLRI. We will carry it in the SRv6 set. We are not. So if you go into the, it's a TLVs in which one of them would be the SRv6 set.
Yeah.
In which we'll put the function part of the SRv6 set. So we are
and the
going clean.
TLV
We are
is
not using label.
Sure. So the TLV
Yeah.
is part of the NLRI. So my point is why, I mean, it's already efficient from a packing perspective. So you don't need any transposition to anything.
Let's discuss part of Hore. We both can discuss this and
Okay. Sounds good.
Converge on it. Sure. Yeah.
Thank you.
Okay.
Thank you so much.
Yeah, next one in the queue, Shriyari, really fast, if you can.
Very quick, I just want to follow up on the previous comment. Now that I think this is probably a comment not just to the authors but also to the work group. Now that we are going to be proposing NLRI packing where there's a extended set of information in the key, so somebody needs to take a look at to see whether this is the right direction that we want to have NLRI grow. Today we are talking about few fields, and then as this progresses, this may lead to a very fat NLRI, something that we should take a look at to see whether this is the right direction.
A quick comment, Sherry. I think we're talking about the the non-key TLVs, but in general, yes, I think we welcome the discussion on this.
Okay, Shraddha, very fast also.
Yeah, so I just want to ask a follow up on the previous question on SRv6 SID. So the in MPLS architecture, there is a prefix and there is a label. So you need a mapping from prefix to label, and that's why you have in the NLRI a prefix and a label. I see that you're proposing SRv6 SID in the encapsulation, and what is the need for for SRv6 SIDs which are IPv6 prefixes? Why do you really need this kind of a mapping from prefix to a SID? If you can clarify that will be useful.
So, Shraddha, as you are aware that SRv6 SID is composed of locator and the function and the arguments, and we can carry a full SR6 SID or as an encapsulation information, or we can carry a variable part like a function which will change with each transport. So that's what we want to carry in the TLV.
Yeah, it will be useful if you can describe that use case and why you are proposing that.
I think in the future revisions we will describe. Sure.
Thank you.
Okay, Aibo,
Thanks,
you will
Rajesh.
be the next. Aibo, you will be the next one, but I'm really sorry, Kaliraj, we have to move forward. Then, so I will close the queue after Aibo. Really fast, few seconds. Okay. Aibo, go ahead.
Hello, can you hear me?
Yes, go ahead. Really fast.
Hey, Aibo.
Yeah, I think it's clear to use the E and C as the NR key, but I have a question that I say that you also use a row type in the NRI. So I want to know whether we may define more row types for the we may use the row types to specify which type of the encapsulator we may use or not.
That's a good question. I think right now the approach we have taken is to use one route type and actually signal multiple encapsulations on it. That the option of signaling a different route type for different encap was considered, but then that still results in the advertisement of multiple routes. So we decided not to do it. But that's something again we can discuss.
Okay, thank you. I think it's clear.
Okay, yeah, we have to move to the next speaker now. Shraddha, I think you are the next one. Let me open your slides.
Hello.
Yeah, we can hear you.
Yeah, my name is Shraddha Hegde from Juniper Networks, and I would like to present Seamless SR on behalf of my co-authors. So this draft has been presented multiple times in Spring Working Group. Next slide, please. In the initial versions of this draft, we had use cases, requirements, and the solution, everything in one document. We got a feedback that solution, there has to be a separate requirements and use cases and a separate solution document. So we split this document into two. The first document, it covers the requirements and use cases, and it is completely neutral from the perspective that it focuses on what would be the requirements from an operator perspective and what would be the requirements from deployment perspective, and it does not refer to any solution, or it does not drive any inspiration from the solution space. And the second document is the solution document. So this document describes how the requirements and use cases described in the first document will be addressed using BGP protocol extension, BGP-CT, that my colleague will present later. Next slide, please. So the basic requirement for seamless SR architecture is large networks, having multiple domains. The requirement is to be able to build multiple differentiated paths or intent-based path end-to-end across these domains. So seamless SR is a distributed solution. The requirement is to be able to come up with a distributed solution that does not use, there's no single device that would have the complete knowledge of the entire database of the entire network, but sort of the independent domains will advertise their reachability and then stitch them together at the border to build an end-to-end path. So you can think of this as an extension to seamless MPLS architecture. In seamless MPLS, BGP-LU was mainly used, which provided only best effort path end-to-end. Whereas in seamless SR, it is an enhancement where you can create multiple end-to-end paths using BGP-based extensions. So the first requirement that we wanted to cover as part of this is AS and IGP domain and how these different domains are organized in the network. We have taken some common deployment cases. It's not an exhaustive list. So the first one is multiple AS connected with eBGP, where you have AS1, AS2, AS3, as seen on the right side first diagram, and eBGP is used to connect these domains, and whatever solution space has to address this kind of a deployment. The second one is a single AS with multiple IGP and same border node. So if you see ABR1, ABR2, these are on border nodes, and they have on the left side an IGP and on the right side another IGP. So there's a common border node, and you can see that they are connected using IBGP sessions. The third use case is a single AS, multiple IGP, but no common border. So you can see that the ABRs are separated. There is no common border. They are all same AS, like AS1. The domain 1, domain 2, and domain 3 are all using AS1. But there is no common border node, and they are still connected using IBGP sessions. And these are kind of AS and IGP domain requirements that have been covered in the draft. Next slide, please. So the requirement is also to be able to cover heterogeneous tunneling technologies in each of the domains. For example, SRMPLS with IPv4 and IPv6, SRMPLS with dual stack, SRv6 tunneling end-to-end, and then SRTE as defined by the segment routing TE policy. Should also cover FlexAlgo for SRMPLS and SRv6. And additional requirement is also to be able to cover RSVP and LDP based tunnels, as well as pure IP fabric which is incapable of supporting MPLS or SRv6 tunneling mechanisms. Next slide, please. So the other type of requirements that the document talks about is various SLA requirements. So various constraints that needs to be satisfied when you build an end-to-end path. So latency, delay variation, and link loss, the end-to-end bandwidth constraints, link inclusion exclusion constraints, link node and domain inclusion exclusion constraints. The next one is an ability to build diverse paths end to end, including diverse paths that satisfy SRLGs. So the next one is a use case specific to data sovereignty, where the constraint might be applicable to only a subset of domains, and it may not be applicable to other domains. And you need to have the ability to build an end-to-end path that satisfies these constraints only in subset of domains. So in addition, also service function chaining requirements, where the service function chains may be located, the multiple service functions may be located across different domains. Next slide, please. So we also want to focus on merger and migration requirements. So the networks are always evolving and changing, and we have to capture the requirements arising out of these constant change in the network. So as part of these mergers and migration requirements, we have covered these aspects where a solution should interoperate with existing seamless MPLS solution, which is based on BGP-LU. So if certain nodes are not upgraded to the new solution, you should still be able to create an end-to-end path, and this new solution should interoperate with BGP-LU. So another aspect of these mergers and migration is use cases that would require option A and option B type of deployments, and these intent-based paths end-to-end should cover those cases as well. So the next one is the interdomain intent translation requirements. This you can imagine arises out of mergers, where there may be another network that that is acquired and that uses a different intent mapping, and so the solution should be able to map these different intents represented using different notations in the two domains. So it should also have native support for best effort paths. So you should not require to run two different families for, be able to one for best effort and another for intent-based paths. So the solution should be able to natively support best effort paths. And it should also interoperate with other tunneling mechanisms, such as like one domain having SRv6 and another having MPLS and so on. So next slide, please. So other aspect is scalability. So the 5G networks are expected to grow to a very large number of nodes in the network. So it should support up to 1 million nodes. Access nodes may be very low, might have very low rib and fib capacity. So the solution should be able to address these cases and make sure only required routes are downloaded in the access routers. The solution should also have a scalable response to network events a network event happening in one domain should not propagate into another domain. So that would guarantee a very that would make sure a scalable network growth. So minimize service routes on border nodes, and then so as part of scalability, we've also captured the requirement to automatically filter the routes on the access nodes. So BGP has mechanisms such as based on policies you can filter the routes that a node receives, but that is operationally very very heavy. So as a requirement, we also propose that the solution should have an ability to automatically request only the routes that only the PE endpoint routes that it really needs to connect to. And that has to happen based on, I mean, when you receive a service route, you based on what endpoints the service route has been advertised from, the access node should only get those infrastructure routes. So non-MPLS solutions should support summarization, and the solution should also have ability to reduce fib scale on border nodes. Next slide, please.
Yeah, Shraddha, you are getting really out of time. You really need to wrap up.
Yeah, sure. I'll quickly cover. Yeah, so we have also captured other requirements like availability, operations, and traffic steering requirements, and interaction with other approaches such as centralized approaches, and also multicast requirements. Like in this, if you're building a network for this kind of an architecture, what are the multicast requirements? That's covered in as well in the draft. Next slide, please. So we are requesting review and comments, and the BGP car problem statement also talked about similar requirements. So we are talking to the authors of BGP car problem statement. We've not concluded anything, but we are talking. So that's pretty much completes my talk. Thank you.
Thank you, Shraddha. Kairaj, you are the next one.
Hi, everyone. Can you hear me?
Yes, absolutely. Go ahead.
Thank you. So thank you for the opportunity. I'm going to present the BGP class 4 transport planes today. Next, please. Next slide, please. So thank you for the previous two speakers who have explained the problem statement really well. So I'll just share the agenda and then go directly to the solution. We can skip the problem statement. So I'm going to actually this idea was presented in the previous IETF 108, and I'm going to recap a bit of the solution and advantages, and then changes to the drafts and some sharing, share some learning from the implementation, and introduce related drafts. Next slide, please. Yeah, this problem statement is what is explained by the previous two speakers. So I think we can go to the next slide. So the way BGP-CT solves the problems that have been described is like, so the tunnels of the similar characteristics, the operators can classify them into transport classes. And the transport class is a construct that is identified by a 32-bit color. And this supports different types of transport tunnels, RSVP, SRT, FlexElgo, IP tunnels, SRv6, it can be anything. And the BGP-CT is a new BGP transport layer address family. It's like LU, where you can say with RD and RT, which follows 4364 procedures. So it's SRP76. And you can think of it as like even today we carry transport layer routes in L3 VPN in some scenarios like career. So in a way, there is a personality of this address family that is present deployed in the networks even today. And we are just doing it clean, that we are separating out as a new SAFI and to carry the transport routes, so that transport routes can be given separate behavior than the service routes. And so we reuse the existing mechanisms of the route distinguisher to distinguish different instances of a tunnel endpoint. And we use a new type of route target, new format of route target to identify the transport class that the route belongs in. So BGP extends the tunnel across interdomain boundaries by preserving the same transport class end to end. Basically, it preserves it by resolving the BGP next hop over the tunnels belonging to the same transport class without allowing any fallback at the transport layer. And it follows the 4364 option C style procedures to create swap routes on the domain boundaries. And these domain boundaries could be either ABRs, which are doing BGP next hop self, or it could be ASBRs, which are doing BGP next hop self. So whichever node is doing a BGP next hop self for the BGP city routes, it becomes a border node, which stitches two different types of tunnels. And that stitching element or emitting forwarding state could be either MPLS or SRv6. So in this draft, we basically focus on MPLS because that is the de facto deployed technology today. And there are other drafts which explain other technologies. And it works in conjunction with option A, option B scenarios as well, so that your transport class can be preserved across the boundaries. And the way service routes, they resolve over a resolution scheme. Resolution scheme is nothing but an ordered set of transport classes, which is like one color followed by another color or default transport class, the default tunnels. So they resolve over a resolution scheme by virtue of carrying a mapping community. So the mapping community is nothing but a BGP community that maps to a resolution scheme. And for service routes, they use a color extended community, which by default says resolve over color N with an optional fallback to best effort tunnels. And the transport target that we have defined here, that is on the BGP city route, that resolves strictly on the color N tunnels. That's for the reason of preserving the transport class end to end. Next slide, please. So this is just a recap to show what does the format look like. So it just has no new things. It's the plain boring RFC 4364 well-proven format where we have the transport route target and the city SAFI. So we just have new code points for the SAFI and the route target so that there is no collision with the service layer. Next slide, please. So this just shows a pictorial representation of whatever we discussed so far. So in this case, PE11 is the egress node, and it has multiple color tunnels. And we see two domains, AS1, AS2, where AS2 has two domains again with the ABR in the middle. So they are like three transport domains, and they are different LSB tunneling protocols in each domain of various colors. So we can just provision the transport classes and advertises these routes in CT so that the ingress, either at the ASBR11 or at the PE21, the service routes can resolve over these transport class tunnels in the same manner. Next slide, please. So I just wanted to take some time to recap using or reusing the advantage of reusing the 4364 encoding. So the route distinguisher, which is a well-known, well-deployed way of distinguishing VPN route through an RR. So it just avoids the use of multiple loopbacks on egress PE that satisfies the requirement. It avoids path hiding when the translating RR ASBRs. And it allows unambiguously identifying the originating PE for debugging. And it also allows anycast transport endpoints, which can participate in multiple domains, which may not necessarily agree on the color. And it also allows path selection after stripping the RD when necessary. So this is helpful for faster convergence and also to keep the churn local to the domain where the churn is happening. So basically, RD is a good identifier of convenience. It is well deployed, and it can be used when needed to go through RRs, ASBRs without path hiding, and we can strip it when not needed and do path selection. And it is preserved end to end. And the route targets, that's even more helpful to propagate the transport class. It allows forming Venn diagrams of color domains as desired, where, for example, the core network is having more fine-grained colors than access networks or any new use cases that can come in future. And yeah, treating color as an attribute rather than part of the NLRI, it just helps not having to rewrite the NLRI or having to guess where the color is coming from. It's just always in the route target. And another important use of reusing 4364 is able to use route target constraint procedures. So the service layer routes and the transport layer routes now can have a clean API where we can discover the transport classes that the end PE needs, and it can request in the BGP-CT layer. So that becomes an on-demand next hop. It will only require the transport routes that it needs. And it just reuses the time-tested, well-deployed 4364 machinery, which is already deployed in hop-by-hop fashion across multiple domains. So it just cuts down the experimentation and implementation times. It improves reliability of the solution. Next slide, please.
Yeah, you have to speed up, Kaliraj.
Yeah. So these are the updates. So we just added some example topology with more illustration and PLSOM section. And we found it to be helpful to add how CT helps in the redundant ABR scenario, where there could be forwarding loop between the RRs. And we also added scaling consideration section, where we recommend 8212 by default, and the usage of route target filtering and MPLS namespaces. Which is a new concept that can be applied to both LU and CT networks to deal with scaling, because this can help with seamless MPLS networks. And scaling is the main problem that it's an important problem that is agreed upon. And we added the applicability to the network slicing section, where the transport class provides a topology slice part of the transport slice. And we have support from the field. Thank you for the co-authors. And we have working code. Next slide, please. Next slide, please. Yeah. So we can go to the next slide. I'll explain with the topology what I'm talking about.
Yeah, you are really getting out of time, Kaliraj, so you really need to speed up because we have still a free presentation after you.
Sure. So this one is just talking about plain BGP machinery, where when we have route reflectors doing next hop self, there could be forwarding loops formed between ABR22 and ABR23, two route reflectors doing next hop self. So there's an easy way to avoid it using CT, where you don't provision the color tunnels between the ABRs. So automatically the route resolution procedures will not have ABR choose other ABR as the next hop and only will choose the ASBRs. So that was just another anecdotal note that I wanted to share. I think I'm done. I can take any questions here or on the mailing list. Oh yeah, I'll take a moment to share the related drafts. So we have drafts in PSEP, SRv6, and route target constraint that are being presented at the working groups. Thank you.
Swadesh, you have 30 seconds if you have a question, even less than that.
Yeah. Yeah, I see you are carrying a color route target. So do you suppose the import semantics as well as do you think a particular route can carry multiple intents hop by hop? Is that what you're looking at by putting it in the RT? Because
yeah,
you
so
can have
the route target
multiple
is
RTs now in
just
the
a
same route.
4364 route target. It has the same semantics. So a route can, at a box, it will map to one transport class unambiguously. But the route can carry multiple route targets so that different nodes in the network can import it into different. So it can help with mergers and renumbering kind of use cases.
but you don't see it carrying multiple intents, right?
It can carry multiple route targets that basically map to the same intent.
Okay, yeah, the requirement is still the same intent in that.
Yeah.
Okay.
Okay, let's move on. Next speaker. Wei.
Hello?
Yeah, go ahead.
Okay. Hi, everyone. I'm Wei Wang from China Telecom. And on behalf of the authors, I will introduce the main content of our draft, which named Layer 3 Accessible EVPN Services. Next slide, please. This presentation contains three parts. First, I will introduce the Layer 3 accessible interfaces for EVPN surveys. And then I will introduce the solution we proposed to simplify the deployment of Layer 3 accessible EVPN. And the last part is about the further actions of this draft. Next slide, please. Okay, this page shows the service interfaces mentioned in RFC 7432, and I believe everyone here is very familiar with them. So let's move to the next slide. The above service interfaces requires the network between C and PE is a layer 2 network. But in most of provider network, CE and PE need to across a layer 3 network. So the above service interfaces should be extended to adapt to the layer 3 network. Next slide, please. Well, we defined logical session in identifier to distinguish the packets from different tunnels, which is related to VNI or SPI. And we also defined three service interfaces, LSI-based service interface, LSI bundle service interface, and SLI aware bundle service interface. They have similar features and requirements to the service interfaces defined in RFC 7432. And the first two service interfaces are easy to implement customer traffic isolation. So we will mainly focus on the RSI aware bundle service interface. And next slide, please. So let's assume the scenario as shown in the figure. If we are the P1, 2, and 3 are EVPN peers, and the customer traffic transmission between PEs rely on VXLAN. The CEs are connected to the sites of customer for its departments A and B. And if we assign a VNI to each department, and each VNI has its own IPVRF on PEs, then each PE and CE maintain an IPVRF for each department of the customer. And the department traffic can be isolated by different VNIs. So there is no need for extending control plane or forwarding plane protocols. And next slide, please. But for deployment, we expect a simpler way, such as deploy an IPVRF to each customer, not to each department. That is to say, all VNI share one IPVRF on PEs. In this situation, each CE maintains an IPVRF for each department, but each PE only maintains one IPVRF for a customer. So the department traffic cannot be isolated by VNIs. Next slide, please. We propose a solution to this scenario. In this solution, we use RSI information to identify different department routes or traffics. And in the control plane, we reuse Ethernet tag ID or ESI to transfer RSI information. When receiving a packet, the PE will look up IPVRF with these two identifiers to determine the next forwarding behavior. And the existing EVPN route type can carry these two identifiers, so there is no need for extending the control plane protocols. And next slide, please.
Wei, are you still there?
Hello?
Yeah, yeah. Do you see the slide?
Okay, I can see. And in the forwarding plane, the protocols need to be extended to transmit the RSI information. And with VXLAN header, we define a S bit. And if a value is 1, it indicates that the field after all bit is RSI information. There is a 1-to-1 mapping between RSI and VNI or SPI, and PEs should maintain the mapping table of them. And next slide, please. Our next step is to refine the extension scheme of control plane or forwarding plane protocols needed by the above solution. And more solutions and comments are welcome. Thank you.
Yeah, we have time for comments. Linda?
For this LSI, is that same as route distinguisher?
RSI is the identifier to distinguish the packet from different logical sessions.
Right. When you configure VIF, you can have a distinguisher to distinguish routes belonging to different virtual network. To me, it seems very similar. So just curious, is that same or different?
Wei?
Hello?
Yeah, Wei?
Hello?
Hello?
Are you able to hear us?
Hello?
Yeah, can I explain?
Wei?
Hello, can you hear me?
Yes, yes, we can hear you. You can answer to Linda.
Oh, okay. And sorry, maybe I missed the question.
Okay. In this case, please take it to the list, and we will move to the next question because we just have 30 seconds remaining. Jorge, next one.
Yeah. Hi. I think you said that you are using the ESI in the routes type 5 to signal this LSI. I don't think you can do that. ESI is for multi-homing and even in the routes type 5. So yeah, you shouldn't do that, I think.
Hello.
Adrian, are you talking a co-author or contributor, or are you taking over the line?
Yeah. I want to answer the question. Is currently we consider using the Ethernet tag or extension or define a new ES type to transfer the LSI information. So if the Ethernet tag can't be used, we can rely on the ESI type. Okay.
Okay, we can take it offline.
Yeah. Please take it offline. We have to move on. Sorry. Tony, you're the next one. Unfortunately, Kaliraj, we don't have time for your last slot.
I'll make it super snappy. It's a short one. Thank you, Stefan.
Okay.
Is my audio okay?
It is. Go ahead.
Good, thanks. So we call it Auto EVPN. Not my idea. A product guy came to me, and first I told him impossible, and then got thinking. When is the architect? And we have Jordan, who is editor of the draft. Next one, please. So I'll just talk quickly what are the drivers of the vision of it, architecture, and then skip most of the details. Yes, please. Next one. Next slide. So EVPN has been widely successful, deployed and so on, and it grew a lot of horns, bells and buttons, and it is not an easy technology to deploy and configure. So you really have two choices these days. You either have a magic controller, which, it's a fine thing, and probably large deployment is a very good idea, but it has its own set of challenges. How do you find the boxes, and how do you know which box does what in the EVPN network, and so on. Or otherwise, you go through the whole exercise of configuring an underlay and figure it out, and then overlay on top, and we know how many variables the stuff needs, right, and how many variants we have. And the observation is actually that a very large part of customers is deploying in a very simple way, pretty predictable way, but they still have to learn the whole rigmarole of complexity to actually understand what to put into the boxes to make them work. So the question basically from our product guys was, can we make it as simple as L2 was? Because it's L2 after all, right? So why can't we just plug in boxes? All right, so we figured out with the Drift we can actually do that. Next slide, please. But of course, we will not support all possible variations. So here is a slide. The links are barely legible. So of course, we talk about Rift. So we talk about IP fabrics, which are built, in a very predictable way, some kind of claw variation. And we figured out that actually with Rift, we have enough information to completely EVPN ZTP without any user input. And the model that we support, but the draft is open, right, is basically IBGP, and we put route reflector on the top of the fabric, and we run integrating routing and bridging on the leaves, which lots of people are moving towards that. A couple of things we found which are non-obvious is that if you want to stretch VLANs, well, you can't derive the same values, on all the fabrics. So we allow for an optional fabric ID, and that will allow you to stretch VLANs. And we can automatically derive stretch and non-stretch VLANs by doing that. What else was interesting? Well, you end up with something where you just have to tell the fabric what is the top of the fabric, otherwise there's absolutely no input and EVPN comes up. Next slide, please. And those are some first details. So basically, the draft will flesh out how you derive all the variables that are necessary, you know, like a cluster ID, whatever the loopbacks and router IDs and AS you're on and so on. That will be all filled in because the draft right now is pretty naked. We just didn't have time, you know, to put all the details. Next slide. And it will also contain type 5. Right, so there's a little bit that we'll have to put additionally into Rift if we want to support especially multi-plane. It's an interesting problem. And we can also put in Rift basically minimal telemetry for the whole thing, right? Because people, it's kind of hard to figure out whether the whole thing works. People want to know, you know, how many L2, type 2 and type 5 routes you have, and with all the BGP sessions came up and so on and so on. And we can basically stick it into the key value store of Rift, flood it up, and then the top of the fabric, just like today, you see the underlay. You can also look whether the whole OpenVPN came up and is sane. Nothing too ambitious, but, you know, makes the stuff as simple as sticking L2 switches together again. Next one, please. Right, so next revision will have the algorithms, and we also do the type 5 IRB variables because we kind of commented them out, simply no time. We also talk about how we put the stuff into the key value store. Co-authorship is welcome. There is an open source Python, something like that can be easily hacked in. And another interesting observation is that if you participate as Leaf only, you only need the Leaf implementation for Rift, which is far, far simpler than the whole thing. And that's the end of my shtick. Any questions, observations?
Quick question, Tony. Is there any relationship with the BGP autoconf work which is done in IDEA?
Well, they're mostly concerned about how to bring up session. I mean, I'm not sure which draft we're talking about. I mean, I'm aware that we're talking now about the V6 over V4 over V6 draft, and of course all the auto session for BGP. I'm very well aware of what's going on there. I'm not aware of the stuff you're talking about.
Yeah, Jeff presented something yesterday regarding the work of the design team in IDEA working on BGP autoconf.
No, if it stretches beyond just appearing without configuration, then I'm not aware of that.
No, I think it's mostly, this is mostly discovering the functions of the node, establishing the BGP sessions and so on. Yeah, of course, this is not exactly the full scope you are doing, but I'm wondering if at least some part of the work could be reused.
Let's Jeff chime in. We talk a lot, but he never told me about it, or maybe I didn't listen. Jeff's on the mic.
Jeff?
Yeah, no, it isn't. The solution requires Rift and underlay, while auto discovery talks about BGP being the protocol, so they are really independent.
Okay. Wim, go ahead.
But Jeff, could you not extend the BGP auto configuration? I mean, I think it's mainly to establish the BGP configuration, but could you not extend it to include some of the parameters that are needed for EVPN? I think you could not.
That's a
the
question.
scope of auto discovery is to establish BGP session. It's not to establish EVPN session.
No, sure. But yeah.
Wim's observation is that to really be able to derive that stuff, you have to understand what your role is in the fabric. And for that, you have to understand the topology, right? So you can't run it on an arbitrary thing. And yes, sure, you can probably extend other protocols. I mean, you can make ISIs look like Rift at the end, you know. I know, I'm a little bit flippant.
Oh, but you're basically you're exchanging information, right? So it's basically how do you distribute the information? Now you get it. To the various points that needed. Okay, yeah.
AC?
Yeah, I think AC Lindum, Cisco. I'm on the design team with the two Jeffs and Wim. I think the AutoConf will be quite a stretch to take. We have the BGP role to just have a role a router plays to do everything for, and that's really supposed to be plug and play for this work. But also, it generally doesn't go more than one hop, the solutions we're looking at for the data center. So that's not, this isn't within the scope right now.
Okay. Any other comment? Okay, good. Thank you, Tony. We are out of time, so really sorry, Kaliraj, for not handling your last presentation. Thank you all for your attendance, and we will meet again this summer, even virtually or physically. I don't know yet. Okay, thank you, and have a good day.
Yeah, thanks for squeezing me. Bye, everyone.